Today we're going to go back and review Chapter 4, Logarithms. It's been a while since we did these, so a review is in order. What did we do back in Chapter 4? Remember when we dealt with logs? Log is the inverse of the exponent. So log base b of y is equal to x implies that b to the x is equal to y. Remember we had our little wrap. Okay? Base to the outie equals any. So b to the x equals y. Now we also had several rules about expanding and condensing logs. For instance, if I'm adding logs together, that's going to become a multiplication. If I'm subtracting logs, that's going to become a division within the log. So what do we have here? And also exponent. If we have a 2 out in front, that becomes 5 squared. So log 5 squared is log of 25 plus log of x cubed. Well, adding those logs together is the same as multiplying them within the log. And here I've got y squared. Now, subtracting that log is the same as dividing by y squared inside the log. So this expression can be simplified to this expression here. All right, COB, change of base, log of the any divided by log of the base. You can use your calculator to solve these. But if I have log base 4 of 6 is equal to log of 6 divided by log of 4 is equal to natural log of 6 divided by natural log of 4 is equal to log of any base of 6 divided by log of any base of 4. And if you plug any of those into your calculator, you should come up to approximately 1.292. So some of these you might have to go back and remember how to use your calculator and practice. All right, so let's take a look. If I'm given this information, I can find each of the following. Log of base b of 25. Well, remember, I can take the 2 out in front and make this 2 times log of base b of 5. And that's going to be equal to 2 times my value that I'm given here, 2.436. And that would equal approximately 4.892. All right, log of base b, 2/5. Well, remember that this is the same as subtracting each one individually. So I could have log base b of 2 minus log base b of 5. That's going to be equal to 1.2 minus 2.436 is equal to, I'm sorry, this is wrong here. It's just equal to this. I copied and pasted and made a mistake here. The final answer is negative 0.236. So ignore this 4.892 that was just copied from the previous one here. So just ignore that. Log base 2 of 5. Again, I can look at this and I can do log base b of 5 divided by log base b of 2 is equal to 2.436 divided by 1.2 is equal to 2.06. Okay. Again, ignore this 4.892. That was copied and pasted incorrectly there. All right, we will continue on here. No matter how we try to solve these logs, remember we want to isolate what we're solving for and then solve it, and we want to find out what is x equal to. And then third, check your answer at the end using the original equation. So what is that going to look like? Okay, and again, extraneous solutions, there might be possibilities where an answer doesn't make sense. Logs don't like negatives inside. So if I have some number to some exponent 1 is equal to some number to exponent of 2, if it's the same number, well, then we can cancel and set the exponents equal to each other. For instance, if I have 3 to the x equals 3 to the fifth, well, I can actually cancel out the 3's in this case and be left with x is equal to 5. Pretty simple. But what if the numbers are different? Well, if I have two exponents separated by some equal here, well, if we can factor these so that we can make these equal to each other. So if we can make those numbers equal to each other, we can then cancel the exponents, or cancel the numbers and set the exponents equal. So if I have something like this, 9 to the x is equal to 27 to the sixth, well, I can factor 9 into 3 squared. I can factor 27 into 3 cubed. And I can rewrite that as 3 to the 2 times x is equal to 3 to the 3 times 6, or 18. That tells me now that I can cancel out the base, and I have 2x is equal to 18, or x is equal to 9. And 9 to the ninth power does indeed equal 27 to the sixth power. And you could check that on your calculator if you wanted to. All right, second example here. If I have some number to an exponent is equal to some other second number, okay, two different numbers, one exponent separated by equal, multiply both sides by the log exponent. Log exponent then drops down, and we can solve using change of base and a calculator to finish. So what does that look like? If I have something like this, 3 to the x power is equal to 4. Well, I can take the log of both sides. Log base 3 of 3x is just equal to x. Log base 3 equal to of 4. So here x is equal to log base 3 of 4. I can use my calculator to solve x is equal to 1.262. Plug it in your calculator and check that that is indeed equal. If I have the reverse of that, I have log base b of x is equal to some number. Well, remember base to the out is equal to the any. So if I have log base 3 of x is equal to 2, that tells me that 3 squared is equal to x. 9 is equal to x. Log base 3 of 9 is equal to 2, and indeed 2 does equal 2. So that does indeed check out. All right, so fourth example. Log base b of x is equal to log base b of y. Two logs, same base, separated by equals. The logs cancel, and we can just set the any equal to each other. So I have log base 5 is equal to 2x. 2x is equal to log base 5 of x plus 1. Well, the log base 5 simply cancel out. I have 2x is equal to x plus 1, or x is equal to 1. Log base 5 of 2 is equal to log base 5 of 2. All right, if I have two logs, same base number, equals some number, remember we can condense this. It's going to be log base b of x times y. So I have log base b of x plus log base, log base 4 of x plus log base 4 of 8 is equal to 2. That's going to be log base 4 of x times 8, or 8x is equal to 2. Now base, okay, to the outie is equal to the innie. So base 4 squared is equal to 8x, or 16 is equal to 8x. X is equal to 2. And we can check that on a calculator if we wanted to. Log base 4 of 2 plus log base 4 of 8 is indeed equal to 2. All right, graphing logarithms. Steps to graphing, well, how does it move? And we want to take the base function by cutting off the -2 and the 4, and just be left with log base 3 of x. Okay? And so then base to the outie is going to equal x. graph that and then move based on our h and k here. So my h is going to be 2, my k is going to be 4. So what is my base function? 3 log of y is equal to log base 3 of x. Well, switch it around. 3 to the y is equal to x. Base to the out is equal to the inning. So what does that give me if I set up a table? X is 9, y is 2, x is 3, y is 1, x is 1, y is 0, 1/3, -1, x is 1/9, -2. My h is 2, my k is 4. My domain is all real numbers greater than 2. My range is all real numbers. So let's draw this. First, we'll draw the base function in green here, plotting those points. 9, here is 1, 2, 3, 1. Here is 1, 0. Here is 1/3, -1. Here's 1/9, -2. And then draw the asymptote at x equals 2. And we're going to move it over 2 and up 4. So my final answer is going to look like the red curve. So I'll give you a second or two to jot that down. All right. You can come back and check this out if you want to. Now, exponential and logarithmic models. Remember, exponential data shares a common ratio from one term to the next, as long as they're equally spaced, similar to what we did for geometric series, right? So here, looking, my ratio is 3 times 3 times 3 times 3. My function here is going to be f of x is equal to 2 times 3 to the x power. So I'm not going to go into a lot of detail right now, but here are the steps for doing this on your calculator. So if you need to do, come back and revisit this, make sure you know how to do this, okay? Now, some word problems that you might have with interest. So compounded continuously, remember we had this constant E, which was equal to 2.626 something, something, something. Well, so the amount is equal to your principal, the initial amount that you invested, times E to the R, which is rate times time. Okay? Now, if it's compounded on a periodic basis, like annually, daily, yearly, quarterly, well, then we're going to introduce this N, which is the number of times that we're going to compound it per year. So if it's monthly, we would do it 12 times per year. If it was annually, we would just do it once per year. So again, come back and revisit this slide if you need to remember those equations. And here are some other ones. We talked about growth and decay models, half-life, exponential decay. This is used in science when we're trying to determine how much of a substance is left after a certain amount of time. We're talking about seismographs. What is the relationship between different Richter magnitudes? And pH scale, we talked about that as well. So you might have to go back and check your notes from chapter 4 on some of the homework, but if you can remember these, you should be able to complete the homework. And the homework is going to be section, the study guide numbers 1 through 15. So again, we're not going to have a final, but we're going to go through the study guide as if we were going to have a final. And so that will be due. So please finish numbers 1 through 15 on the study guide and turn that in by next class, as well as the copy of the notes from today. So that's all we're going to do.